All right, here we go. We're going to be on page 104, and we're going to cover section 2.4 first. And this section is on function operations. Function operations. And y'all know what a math operation is, right? Like addition, subtraction, multiplication, division, those are operations. And we're going to be looking at all of those, but with functions. And so the first problem that we're going to start with is number 7. And we're given a function f of x is negative 2x plus 3. We're also given a function g of x is x squared minus 5. And they want us to find f of negative 4 over g of negative 4. Now that's the way it's written in the book. F of negative 4 over g of negative 4.
G of x is basically still saying y. Right?
Exactly. All right, so this notation, f of negative 4 over g of negative 4, could also be written as f over g of negative 4. Those mean the same thing. Do y'all see how they're different? So this is actually telling you to plug negative 4 into f and to plug negative 4 into g. And this over here says the same thing. It's just showing the division together, and then this is what's going to plug into both of those. Got it? So what is the implied operation?
Plug in the negative 4 for f and plug in the negative 4 for g.
Okay, so that's what we're going to do, but what is the implied operation? Division. Yes, the implied operation is division. Yeah, okay, so that's the operation is division. What we're going to do, though, is we're going to do what you said. We're going to plug negative 4 into f everywhere there's an x. And then we're going to plug negative 4 into g everywhere there's an x. And f goes on top. And does everybody notice that when I plug in the negative 4, it has to go in parentheses? That's important. And then this is where you're going to take out your calculator. Hopefully you got the one I recommended. And you're going to start with your fraction button. And then you can just input all the numerator stuff and all the denominator stuff and hit equals. And it should spit out the answer.
I know it's important to put in parentheses, but why does it have to be in parentheses?
Okay. For example, down here in the bottom, if you do negative 4 squared without the parentheses, it'll give you negative 16 instead of positive 16. So if you don't put the parentheses, only the 4 will be squared and the negative hangs out front. But with parentheses, it says, hey, this thing has to be multiplied by itself. Do y'all understand? So the parentheses are going to make a difference. Definitely. All right, so if you don't have a calculator, you're going to have to do it manually. 4 times 2 is 8 plus 3. Negative 4 squared is 16 minus 5. And that's going to be 11 over, I think 11? Just 1. And if anybody's trying to input that in the calculator and you need help, let me know. I'll give you calculator counseling. Anybody have a question about that problem?
Will they not give me a fraction on this one?
Yeah.
They just gave me a straight up answer.
What answer?
1.
Oh, well, if it's not a fractional answer, it'll give you a whole number.
No, but if you want it in a fraction.
Well, you can't make 1 into a fraction. I mean, 1 over 1 is 1.
Yeah, but I know. Okay, never mind.
But if it's like 7 over 2, it'll give you a fraction. But if it's a whole number, if it's going to divide evenly, it'll give you the whole number, not the fraction. Y'all want to try another one? Okay. How about a little bit different? I don't know if I'm ready to kick up the degree of difficulty yet. We'll do one that's a little different. 11. Now we're going to be using the same functions. And so just for fun, let's set those off with some color. Same functions, but this time for number 11, it wants me to do f plus g of x. So again, what is the indicated operation? Addition. And did you notice this time they did not give me a number to plug in? And so in this case, we're simply going to take f of x and g of x, and we're going to add them together. All right, here we go. F of x is negative 2x plus 3. Remember, this time they didn't give me a number to plug in, so it's just going to stay x. And then plus g of x, which is x squared minus 5.
Are we still using the same number for the
Nope, this is a different problem. So this time they did not give me a number to plug in. So we're just working with f of x and g of x. And then when you get done here, you're going to need to combine like terms. Maybe put it in descending order. That'd be good math etiquette. What is the biggest exponent? Of all the variables, which is the biggest power? Okay, so the x squared, we're going to write him down first. And then the minus 2x. And then we have plus 3 minus 5. Somebody said negative 2. And do you see for this problem, we don't get a single number answer. We get another function. Okay, so the main thing I need you to notice, sometimes they give you a number to evaluate, sometimes they don't. Are y'all ready for the next one? Okay, next. Number 17. And here we have new functions. F of x, x squared minus 2. And g of x, 5 minus x. And we want to find f minus g of 3. That's what they want me to find. F minus g of 3. And so what is the indicated operation? Subtraction. And did they give me a number to evaluate? Yeah, this time 3. So we're going to plug 3 into f first. And then we're going to plug 3 into g. And whatever we get for those two answers, we're going to subtract. All right, so here we go. First of all, f of 3 is going to be 3 squared minus 2. Yeah. And then G of 3 is going to be 5 minus 3. Everybody see how that sets up though? So this is all F and this is all G of 3. 3 squared is 9. 9 minus 2 is 7. That's what I heard. 5 minus 3. And last, 7 minus 2. And this time we do get a single number answer because they gave me a number to evaluate.
Why is this not going to be easy?
Yeah, this is as hard as it gets right here. Anybody have any questions about that? What do you think? Does it look easy? Am I making it look easy? Well, good, because it is. What if I made it look hard? Would you want to do it?
No.
No, okay. So it's easy. It's just as easy as I'm showing you. All right, so now we'll crank it up a notch, okay? Number 19. Let's do find and let's find this. All snap. There we go. We're going to use the same functions again. This is capital F and capital G. So we're going to be using F and G that we just used because those are capitals. And what is the indicated operation? Multiplication. Oh, and look what they want me to plug in. So everywhere there's an X, I'm going to have to put an A. Okay? Okay, so here we go. First of all, F of A is going to be A squared minus 2. And that's going to be multiplied by G of A, which is 5 minus A. Anybody have any questions about that? Y'all know it's okay to ask me if you have questions, right?
How would you do that? Would it go down to negative 2a squared?
Right here?
Yeah.
No. Who said that? Yeah, it's going to be the 4-letter F word. Foil. Have y'all heard of foil? Yeah, no, you can't combine these because they're not like terms. And you can't combine these. So this is a binomial. This is a binomial. We're doing multiplication. So we're going to have to do the distributive property. So we're going to do A squared times 5. And then we're going to distribute the A squared to the negative A. What is it? Minus, I'll take the minus. I didn't hear the rest of it. A cubed. Everybody see why it's A cubed? Because when you multiply letters, what do you do with their powers? Add them. When you multiply letters, you add their powers. And this A has an understood 1 for a power. So that gives me A cubed. And then we're going to do negative 2 and distribute it. Negative 2 times 5? And then negative 2 times negative A. Negative times the negative makes positive. And that's the FOIL. Have y'all seen it done that way? Here, I'll even label it here. A squared times 5, that was the first. The next two, notice they were on the outside. The next two were on the inside, and then those were the last ones we did. That's where FOIL comes from. It's the distributive property. Are any of these terms like terms? Is this in the right order? We probably want to rewrite it so that it's in descending order. So who would go first? Not 5a squared, no. Because he's got a bigger power, right? He goes first. Then who goes? And is it negative or positive? Positive 5a squared. Next. Last but not least. Now, do y'all understand that if you would have left it like this, that would still be correct? It's not in the right order, but it does have all the terms that are needed, right? So listen to what I'm saying. This is not wrong. It's just not right. This is better, okay? This is good. This is better. This is using your good math etiquette. Yeah.
Will there ever be one where it's just in order already? Like
Oh, yeah. Oh, yeah. Now, are y'all ready to try another one? What? Oh, it doesn't get any harder than this. I think maybe FOIL is the hardest it ever gets. I don't know. Y'all want to try something different? Yeah. Oh, sure. Sure. Oh, and can I make one up? Okay, thanks. So we're going to call this my problem. Okay? This is my problem. And we're going to have f of x equals, how about x minus 2? And g of x equals, and wait a second, I don't know why I put parentheses. We need the parentheses. X squared minus 5x plus 6. Oh, yeah. Let's do that. And let's see if we can find this. If you wanted it harder, that's about as hard as you'll ever see it right there. And I'll give you 60 seconds to work it on your own, okay? 60 seconds is all you get. On your mark, get set, go. Got it? All right, so if you have math skills, You should have got it by now, I think. Let's see how we're going to start this. There's f of x, right? X minus 2 times g of x. Did everybody get that far? Showing f times g. And then is this the FOIL method? No, this is not FOIL because those are not both binomials. This is a binomial, but this is a trinomial. So it's not the FOIL method, but it is still the distributive property. So what we're going to do is we're going to distribute that x to everybody in the second set of parentheses. What is x times x squared? X to the third, right? What about x times negative 5x? Again, when you multiply letters, you add their powers, right? Like the Wonder Twins. And then x times 6. And does that get x to everybody in the second set of parentheses? And now whose turn is it to distribute? Yeah. And so now the negative 2 is going to take his turn and go to everybody. So what is negative 2 times x squared? And I'm going to use a technique that I call the stacking technique. Instead of continuing to write it out on this line, I'm going to line up my terms with the like terms, okay? I call that the stacking technique. Next, what is negative 2 times negative 5x? Plus 10x. Again, using the stacking technique. Last, negative 2 times 6. And now do you see the advantage of the stacking technique? It's going to make it a lot easier to finish and combine like terms. All right, so I'm going to have x cubed minus, how about 7? Plus, and minus 12. And notice that is already in the right order. Have y'all seen that before? The distributive property? Okay, I'm glad that we're recording. You can go back and watch it over and over and over again if you need to, okay? And I think I should do at least one more before I move on to the next section. Let's focus on what's going to be tested over. How about? That sound like a good plan? All right. So we're going to call this my second problem. And that's what I would like you to find. And we're going to use the same functions that I just wrote down. So we're going to recycle f of x and g of x. And again, 60 seconds on the clock. On your mark, get set, go. There you go. Perfect. We're going to put up this -2. Yeah, the B's right here. Using this guy and this guy. We'll put -2 in for all the x's. Yeah, this is good. This one, yeah, not so much needed here, but definitely needed in the bottom. And did you see this button right here? Yeah, that's nice to use too. Yours is, this is a nice button. That makes a fraction. Did you see your fraction button right there? This guy right here. Super nice to use right there. All of these x's need to be replaced with -2. This -2 is going to be parentheses. Well, this is going to be replaced also. Every x has to be replaced with -2. Yeah. Anybody about ready to see it work? All right, let's show you how to set this up. First of all, we're going to need a fraction bar, right? The indicated operation is division. And who's on top? F is. So f of x was x minus 2. And so we're going to say -2 minus 2. Y'all got that? And the -2 that I plugged in, you can put that in parentheses if you want to, but it's not really necessary the way that it's written here. But if you feel, hey, if it feels good, do it, okay? Put it in parentheses. In the denominator, we're going to have g of x, and that's going to be -2 squared. Are those parentheses optional? Not with an exponent, those are mandatory. Next, -5 times -2 plus 6. Everybody see how I set that up? Now, if you had my calculator, the Casio, or I think somebody else had the TI 34, right? You can push your fraction button, which gives you a box over a box, and then you can just fill in this stuff top and bottom. If you don't have a calculator, you're going to have to work it out manually. So what is -2 minus 2? What happens if I take -2 and square it? +4. And in the middle, negative times a negative makes +10, +6. And then combine like terms, we're going to have 14, we're going to have 20, and does 4 and 20 reduce? And the final answer, -1/5, which if you're using the calculator, all you got to do is input this one time and hit equals, and it jumps you straight to the answer. It even gives it as 1/5. Everybody see how that works? Do you understand the phrase plug and play? plug and play. You plug it in, you work it out, right? I think for some of you it may be plug and pray. You plug it in, you pray that it works, okay? Any other questions before I move to the next section? Huh? Yeah, pray that it works. Well, that's pretty much it for that section. Did I do addition, multiplication, subtraction? Did I do one of everything? Let me check and make sure here. Okay, there's division. Okay, good. So I did division, I did subtraction, addition, multiplication a couple of times. I did another division. I think I covered everything, right? Okay, so with these examples, you should be able to be successful on that section. Now we're going to go to 5.3. That's going to take us to page 314. 314. And this is kind of related to what we were just doing. This section focuses on polynomial division. So in the last section, we did all of the operations, right? Addition, subtraction, multiplication, division. But in this section, we're going to focus specifically on how do I divide polynomials. Got it? In other words, if we have a polynomial function and we want to divide it, we need to know how do I do long division, maybe even synthetic division. We're going to talk about some of that stuff. Page what? Did y'all make a note of that? 314. And we're going to start with problem number 1. Let's see here. Anthonicia? Okay. Thought I saw you come in. And just to make sure, Yesenia? Didn't make it. What about Jonathan?
How would you pronounce it?
How would you pronounce what?
The 6 and the 5.
24x to the 6th? No, there's only squared and cubed. Squared and cubed. So anything bigger than a 3 is going to be to the 4th, to the 5th, to the 6th. Got it? And it is important to know how to read this out loud, because if you have to call into math tech support and read a problem to them, you're going to have to know how to read it right. Correct? And some of you are thinking, when am I ever going to call in and read a math problem over the phone? Never mind, okay? You just need to know it, okay? Makes you a good citizen. All right, so what we have here in the numerator, up top, how many terms are there? 1, 2, 3 terms, right? That's a trinomial. In the denominator, how many terms are there? 1 term. Now, this is a special case when the denominator is a monomial. What you want to do is separate into individual fractions. Okay, so we're going to rewrite this problem in individual fractions. So that would be 24x to the 6th over 6x squared plus. And then you keep going. All right, so when is it appropriate to split the fraction up into individual fractions? When the denominator is a monomial. And you got to know what those words mean, right? When the bottom is one term. Yeah, and then what we're going to do is we're going to reduce each fraction separately. So 24 divided by 6 is 4. And which has more x's, top or bottom? How many more does he have? And so the x to the 6th and the x squared, those will reduce and leave x to the 4. Y'all got that? Do I need to say it in a way that rhymes? Because I can do, if it helps you remember stuff, if it's a rhyme, I can do it. I will anyway.
So when it doesn't have, so 36 goes to 6 times. When
Yeah.
it doesn't have, would it just be x or would it cancel out the whole?
Yeah, we'll get there. You're looking ahead, okay? You're running off ahead of the rest of the class. I'm going to have to wheel you back in, okay? So what did we say? 24 divided by 6? This is division, right? And for the letters, listen, if it's a fraction, it is subtraction. Bam. If it's a fraction, you're going to do subtraction. 6 minus 2 is 4. Next, 18 divided by 6. Right? How many x's?
3.
5 minus 2. Okay, now to your question. I've got an x squared over an x squared. When it's a fraction, it is subtraction. What is 2 minus 2? That means I'll have no x's.
Okay.
X to the 0 means no x's. And that's done. In other words, those x's cancel completely.
I don't know if you would just have the x or you would cancel out just the 0.
Right. Well, if you do have an x, it's an understood power of 1, which means you do have an x. But in this case, 2 minus 2 is, and you actually have no x's. As a matter of fact, did y'all know that anything to the 0 power is 1? So x to the 0 actually turns into a 1, and 1 times 6 is 6.
There's no 0. There's no actual 0. So
For a power, you can write it like that. It's just not.
technically, there's no 0. Like, because 0 to the 0 power is technically 1.
Say that again?
What you just said like 30 seconds ago? Anything to 0 is 1?
Anything to the 0 power is 1.
That's not.
Right.
Technically, there's no 0.
Well, what I said is technically not true, okay? I said anything to the 0 power is 1, right? There is one thing that you cannot raise to the 0 power and get 1.
0?
And it is 0. Because 0 to the 0 is undefined. Y'all might want to make a note of that. I'm saying a lot of stuff that I'm not writing down. I hope you're getting it. Okay? What I said is important. Is anything to the 0 power 1?
Yeah.
Or is there one thing that cannot be raised to the 0 power?
Anything raised to the 0 power is 1, but it's 0 to the raised to the 0 is undefined.
Undefined. 0 raised to the 0 is undefined. You can't raise 0 to the 0 power. And that's not even part of this lesson. I'm just throwing that in for free, okay? All right, let's go to number 11. So for number 1, we had a trinomial divided by a monomial. And we said if it's a monomial, you're going to separate and reduce, right? Split it up, reduce the fractions. Number 11, we've got a trinomial divided by a binomial. Also notice that the notation is different. I didn't write it as a fraction. I wrote it with the divided by sign. So if I were to rewrite this as a fraction, who would be in the bottom? So whatever's after the divided by sign goes in the bottom, right? So when you're dividing, by anything that's not a monomial, here we're dividing by a binomial, we're going to have to set it up and do long division. Have y'all heard of long division? Okay, in case you haven't, it works a lot like regular division that you learned back in 4th grade. So y'all remember back in 4th grade, you used to make this symbol when you would divide, and you'd put 36 and you'd put 4, and then you'd divide it, right? So here, the divisor is the x plus 5. The divisor is the one that goes out front. And the x squared plus 7x plus 14 goes underneath. Anybody remember the name of the stuff under the division symbol? If this is the divisor, what is this guy called? The what? Dividend. This is the dividend. Y'all need to know these words. Divisor, dividend. What do you call the answer up top? Starts with a Q. Quotient. And then what do you call that last number you get? Remainder. So we've got the divisor, the dividend. We're going to get a quotient and a remainder. All fun stuff, right? I can tell y'all are excited. Yeah, okay, so let's start long division. It's a pretty easy process once you've done it for about 25 years, okay? So the first thing we're going to do is we're going to ask ourselves a question. Yeah. So the way that I ask it, I say, what would you multiply this by to get this? What would you multiply this by to get this? And the answer is? X, right? X times X is X squared. And so the first thing we need in the quotient is an X. I'll show that one more time. What would you multiply this term by to get this term? And the answer is X. Now, is anybody wondering why I wrote it over here in the middle? It's because I want to keep my like terms lined up. It's going to be to your benefit if you'll keep the like terms lined up. And then what we're going to do with this X up top is we're going to distribute to the divisor. X times X. X times 5. Everybody see what I did so far? Got it? And then when I draw the line, I'm going to change the sign. When you draw the line, you have to change the sign.
Wait, so you multiply the x times x squared?
I did. No, wait, no. I multiplied this x by this x.
Okay.
X times x is x squared. X times 5, 5x.
X times x gives you x squared. That's what you put up top, right?
Right. It's because it gave me x squared. That's why I put it on top. Oh, and did you hear me say draw the line, change the sign? You know why we do that? Because when you did it back in 4th grade, whenever you multiplied, you had to subtract. But I've got a binomial, so I've got to subtract both of those. It's going to change the signs. All right, so what's going to happen to x squared minus x squared? Cancel. What about 7x minus 5x? 7x minus 5x. 2x. Plus 14. Then the 14 drops. And then we rinse and repeat. So now we're going to start over again with our questioning. Now, what would I multiply this by to make this? 2. Ask me.
Well, no, it's because I thought it was going to be an egg. So I was going to ask you to put it on top, but no, she's it.
Okay, so whatever goes on top is going to have to multiply to give me this guy. Got it? So when I started, the guy on top had to multiply to give me x squared. Now I'm on a new line of the problem. And this is the lead term. So now we're going to say, what would I multiply x by to get 2x? And that's going to be 2. Positive 2, correct? And then we're going to distribute. 2 times x. 2 times 5. Draw the line. Change the sign. Draw the line, change the sign. It'll work every time. And then 2x minus 2x. Cancel. 14 minus 10. Oh no. We got a remainder. That's a remainder of 4. And what is the x plus 2 called? Quotient. So we can say this. Right. Say it again. Yes, let's include the remainder. All right, so the reason I wrote it the way I did, sometimes it's going to ask you to write the quotient and the remainder as a function. And so this is the quotient as a function and the remainder as a function. Y'all see that? They may also ask you to write it as a polynomial, okay? Or they may ask you to write it this way. X plus 2 plus 4 over x plus 5. This could also be a way that they want it written. Write the quotient and the remainder all together. So again, here's the quotient. And sometimes you put the remainder over the divisor. Especially if you're doing it with just numbers and no letters. That's the way you would write it as a mixed number, right? Like 3 1/3 or 2 1/2. It's like a mixed number.
Wait, how would the other two? You said
Well, this is not a polynomial because it has a fraction with x in the bottom.
no, that's what I'm saying. Well, how would you write it? How would you write it being a polynomial?
As a polynomial, this is as close as I can get as a function because as soon as you have a fraction with a letter in the bottom, that's not a polynomial anymore. That's called a rational function. So I guess they could say, how would you write it as a factor? I don't know. Y'all write it down, okay? Do you understand the process? Okay, we're going to do another one then. Let's try number 13. And the instructions, again, it just says divide. The instructions say divide. That's kind of obvious. They have a division symbol. So what's going to be the divisor this time? Okay, good. So we're going to have 2y plus 4 out front. And then what's the dividend? Okay, now listen, I'm going to have to stop you right there. Do y'all see the exponent start at 3? And every power below that has to be represented. So 3, 2, 1, and none have to be represented. Do I have a y to the 1 power? Well, when I'm writing it down over here, I've got to represent that. So how many y's to the first power are there? I don't see any.
Zero.
Yeah, none.
Do we have to write it?
You need to. There's a big difference between have to and need to. Okay? Do I have to wash my clothes every week? No. Do I need to? Yeah. So I don't stink. Okay? So some people can get away without doing it, but it's a lot easier on you if you do it. Yes, sir.
So to make it easier before we start that process, can we somehow combine that 4y squared cube and that 6y squared?
Into one term?
Yeah.
No.
No.
And the reason is when the exponents don't match, you can't add or subtract them.
But if they were the same.
I'm sorry?
If they were the same.
If this was a 3 and this was a 3, then you definitely could combine that to make it easier. Yeah. But if the exponents don't match, then they're different terms. You can't combine them. But if you're missing an exponent, that term has to be represented, okay? So do you see now I've got 3, 2, 1, and none. Everybody's represented. All right. Now we can begin the process of division. Are y'all ready? So the first question, what would I multiply 2y by to get 4y to the third?
Y, 2, 3.
2y squared. Right? 2 times 2 is? Y to the second times y makes y to the third. Do y'all understand what it is you have to look for? It's always the lead term to make the lead term. What would I multiply 2y by to get this guy? And that's the answer. And then I'm going to distribute. So we're going to get 4y to the third. You should always get that because you designed it that way. And then what is 2y squared times 4? 8y squared. You follow me?
Yes.
Now, when I draw the line, I have to change the signs. Draw the line, change the sign. 4y to the third minus 4y to the third, those cancel. What about 6y squared minus 8y squared? Plus 0y plus 14. And then everybody else comes down. And then we're going to rinse and repeat. So now what would I multiply 2y by to make this guy? Something times this to make this. Well, he's already a 2. I don't need to multiply him by 2. I'll crank him up to a 4.
Would it be negative 1?
Well, he's definitely going to have to become negative.
Negative 1y squared.
Okay, negative 1y squared or just negative y, not squared though. Bam. Just y. Because y to the 1 times y to the 1 makes y to the 2. Right? And it's negative because a negative times a positive makes negative. Are you with me? Is this easy? Oh, it takes some practice, okay? It's not that bad. 25 years, you'll be perfect, okay? So here we go. Negative y times 2y. makes negative 2y squared. And then what about negative y times 4? Yeah, but a negative times a positive makes negative 4y. And now do you see why we needed that placeholder? We needed somewhere to line up that term with. All right, so next, don't forget, draw the line, change the sign. And so now those will both become plus. Negative 2y squared plus 2y squared, cancel. 0 plus 4. And then the 14 comes down. And we're to the last step. We're finally to the last step. So what would I multiply 2y by to make 4y? Positive 2. And distribute. 4y. 2 times 4? 8. Draw the line. Change the sign. And then combine. I knew I could make it rhyme. Another time. Never mind. 4y minus 4y. What about 14 minus 8? 6. Oh no, I got a remainder. So let's write that as function notation. The quotient as a function of x. I'm sorry, as a function of y this time. Two y squared minus y plus 2. There's the quotient. And the remainder as a function of y is 6. And then let's write it the other way just for fun. 2y squared minus y plus 2 plus 6 over what? The divisor, which could actually be reduced to 3 over y plus 2. Bam, if I want to. Y'all see what I did there at the end to reduce it? So 6, 2, and 4, all three of those terms can divide by 2. So you have to do all of them or none of them. It's an all or nothing thing. And I've got one more example that I have to do before I can finish it up today. And if you're wondering, I've got 15 minutes left, okay? So I still have plenty of time. Anybody have any questions about that? Yeah, that's why they call it long division, because it takes a long time to do it. But y'all remember that fits right into our class motto. Y'all remember our class motto? I didn't tell y'all the class motto? The more work it is, the more fun we have. That's our class motto. Did y'all know that? You don't have any say in the class motto, okay? Okay, number 17. Hey, quick question. Do I appear to enjoy what I'm doing? Really? Good. Can you imagine if I stood up here and I was monotone and I acted like I would rather be home and yeah. No, I got to tell you, I would rather be here than at home. Math is my meth. Math is my drug of choice, okay? I'm high on math.
Like same one, same notes, or
Oh, same section, same type of problem. Can y'all see it is long division? I've got a divisor, that's a binomial. I've got a dividend, 1, 2, 3, 4, 5 terms. That guy's got 5 terms. And for the dividend is every power of the variable represented. 4, 3, 2, 1, and none, right? All of them are represented. That's good stuff. So let's set it up. I've got x squared plus 2. We're going to divide that into 2x to the 4th minus x to the 3rd minus 5x squared plus x minus 6. Now, do you at least know what question to ask?
what gives you 2x squared?
Okay? What gives me 2x to the 4th if I multiply x squared by it?
2x squared.
Well, I'm going to need a 2, and the squared is going to have to be a 4th.
Yeah, so it's 2x squared.
So 2x squared is what I'm going to start off with. And do y'all see where I wrote it? Like terms lined up, right? So what is this term's coefficient?
1.
So 2 times 1 is x squared times x squared,
4. Right.
x to the 4th. And then remember, we're going to have to distribute to this guy too. So 2x squared times 2. 4x squared. Do you see where I wrote it? Keeping my like terms lined up. You follow me? You better freaking ask me if you have a question.
Wait, so you wouldn't just put it to the side of it? You would have to put it beneath the one it is?
Right. Because I got to keep my like terms
Like,
lined up, okay? If you wrote that here, you would be tempted to add those, and they're not like terms, okay? Now, are we good? Okay, now watch this. Draw the line. Change the sign. And they both become minus. And the x to the 4ths are going to cancel. Look at the x to the 3rd. He's going to fall through the gap. Negative x to the 3rd, he falls through. My x squareds combine. Negative 9x squared. Everybody else? Plus x minus 6. Everybody else falls down? Whew, and that is step number 1 done. Step number 2. What would I multiply x squared by to get this guy? Negative x. Right? Because a negative times a positive makes x squared times x. X to the 3rd. And don't forget to distribute. Negative x times 2. Negative 2x. Do you see where I wrote it? Keeping my like terms. Line. This is not something you want to do in a hurry, okay? You want to go slow and take your time. Draw the line. Change the sign. Negative 9x squared falls through the gap. I've got a plus 3x, and the minus 6 falls down. These guys cancel. And if you're wondering when is this ever going to stop, this is the last time. Last step. What would I multiply x squared by to get this guy.
9x. No, just 9.
Oh, I almost hurt my neck. You made me snap my neck around. This guy to get this guy.
Negative 9.
-9. All right, so -9 times x squared. Have y'all noticed that these have to match every time, these lead guys? Look, match, match. They always have to match there. And what about -9 times 2?
Plus 18.
Eventually, it's going to be -18. But then when I draw the line, change the sign, then it's a plus. And then the 3x falls through. 18 minus 6. All of that is the remainder. And all of this is the quotient. And so then we could say the answer is 2x squared minus x minus 9 plus 3x plus 12 over what? Yeah. And that may be the most common way you're going to see the answer written right there. You could also write it as functions, right? Q of x equals and R of x equals. Anybody have any questions about long division? Is it pretty long? Okay. Is it fun? I'm so sorry. I enjoy it though.